Okay, let's discuss the third partial exam on 3171. First problem, we have fx equal to cube root of x. Third root, g of x is equal to 3x minus 3. Okay. H of x is equal to x cubed. Find the value of each expression. Okay, expression A, we're looking for f compose g evaluated at 7. All right, follow the definition of a composite function. It is f of g of 7. We apply 7 first because we apply g function first because g is close to 7. So g of 7, 3 times 7, 21. 21 minus 3 is 18. All right, so you get 18 as a g of 7. F of 18 is cube root of 18. And that's it. There's no way to simplify it. That's our best answer, cube root of 18. Okay, B, H compose G compose F of 9. Okay, it's just longer, but it has a same idea. So you apply F to 9, you get a value, and then you apply G to this value, and then you apply H to the second value. Okay, so F of 9 is cube root of 9. Be careful, cube root of 9 is not 3. Square root of 9 is 3. Cube root of 9 is cube root of 9. We don't have any simplified formula. All right, and then let's check g of cube root of 9. It is 3 times cube root of 9 and minus 3. Once again, it's just such complex expression. There's no way to simplify. And then you apply h. So it's 3 cube root of 9 minus 3. The difference cubed. You don't have to simplify it. That's it. All right, that's the first one. And second one, we'll still talk about the composite function. We have fx equal to 3x minus 1 over 2x minus 2. G of x is equal to negative 2x plus 4 over 3x plus 5. We're looking for the composite function of the domain. A, we have f compose g. We want to find the expression, so we apply it to x. By definition, it is f of g of x. So g of x, this is g of x. So whenever you see x in the in the formula of f, you're going to write this g of x. So it's 3 times negative 2x plus 4 over 3x plus 5. That's 3x and minus 1 over 2 times negative 2x plus 4 over 3x plus 5 and minus 2. All right, and then we multiply top and bottom by the denominator of the numerator. We multiply it by 3x plus 5 for the top and bottom. Okay, so it becomes, the numerator becomes this 3x plus 5, they are cancelled. So you get 3 negative 2x plus 4, 1 times it minus 3x plus 5. And here, 3x plus 5 cancel with this one. So you get 2 negative 2x plus 4 minus 2 times 3x plus 5. All right? And then let's continue the simplification. 3 times negative 2x, negative 6x plus 12 minus 3x minus 5 over minus 4x plus 8 minus 6x minus 10. Just follow the formula. So we have negative 6x minus 3x, negative 9x. 12 minus 5 is plus 7. Negative 4x minus 6x, negative 10x. 8 minus 10 is negative 2. So this is the formula. And the domain, what is the domain? You see, here this is denominator. The denominator cannot be 0. So you get 3x plus 5 is not equal to 0. And then this is denominator. Negative 10x minus 2 is not equal to 0. So here x cannot be 5 over 3. Here x cannot be negative 1 over 10. So what is the domain? Domain is the set of all x not equal to. X is not equal to 5 over 3, and x is not equal to 1 over 5. Right? That's all. Part A. Part B, we compose f with f itself. So you have 3, and whenever you see x, you get 3x minus 1 over 2x minus 2. And then minus 1 over 2 times 3x minus 1 over 2x minus 2 and minus 2. Okay, you see here, this is that expression x. And then you multiply top and bottom by 2x minus 2 for top and for bottom. We want to simplify this denominator. So it's 3x minus 1 minus 2x minus 2. 1 times it, but it's a subtraction. So it's 3x minus 1 minus 2 times 2x minus 2. And we continue the simplification. It's 9x minus 3 minus 2x plus 2. Here's a 6x minus 2 minus 4x plus 4. What is it? So it's a 7x minus 1 over 2x plus 2. That's the expression. What is the domain? You see here 2x minus 2 cannot be 0 because it's denominator. And 2x plus 2 cannot be 0 because here is the denominator. So the domain is a set of all. Here x is not equal to 1. Here x is not equal to negative 1. It's a set of all x such that x is not equal to 1, and at the same moment x is not equal to negative 1. You have to remove both points together. Right? That's all. Second computation. The computation for the second problem. Okay, now let's see problem 3. Problem 3, we're looking for the inverse function. So y, we call y, we call fx y. 3x squared minus 2x squared. And the important condition is that x is greater than 0. All right, so we're going to solve x in terms of y. So 2x squared y is equal to 3x squared minus 2. I'm going to move 3x squared to the left side. 2x squared y minus 3x squared is equal to negative 2. And factor out x squared. 2y minus 3 is equal to negative 2. So x squared is negative 2 over 2y minus 3. And remember here x is positive. We want to take square root. You choose a positive square root. And then you exchange x and y. Before you exchange x and y, it is still the original function. Here you must exchange intercambio, exchange x and y. All right, so this is f inverse of x. This is f inverse of x. All right, problem 4. We have the function f equal function maps negative 3 to 5, negative 2 to 9, negative 1 to 0, 11, and 1, negative 5. Okay, so we're looking for f inverse. F inverse, you just get those pairs, but interchange x and y. That's f inverse. All right, and then we're looking for f inverse of 5. F inverse of 5. See which one is the first. This one. This is 5. 5 is input. So f inverse of 5 is negative 3. And f inverse compose f of 0. See here, f inverse of f of 0. What is f of 0? F of 0 is 11. So it's f inverse of 11. And what is f inverse of 11? It's a 0. All right, so that's the answer. Here, 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 and here. Okay. problem 5. Find the vertex and the symmetric axis for the quadratic function fx equal to 1/2 x squared minus 2x and plus 1/2. There are two ways to solve it. First, you can complete the square. Second, you can recall the formula. Remember, what is the coordinates of vertex? B over 2, negative b over 2a. 4ac minus b squared over 4a. Okay, this is a vertex. And the symmetric axis is x equal to negative b over 2a. Okay, a is 1/2, b is, okay, a is 1/2, b is negative 2, and c is 1/2. So let's follow it. It's a negative, b is negative 2, 2 times 1/2 is 4, a is 1/2, c is 1/2 minus b squared over 4 times a. All right, so what is this? This is 2 times 1/2 is 1. Negative 1, negative 2, so it's 2. Here's a 1 minus 4 over 2. So it's a 2, negative 3 over 2. This is a vertex. The symmetric axis is x equal to this expression. But this one is a x coordinate. So x equal to 2 is the symmetric axis. Symmetric axis, right? And that's it. Problem 6. We're trying to form a polynomial with a required condition. So it has zeros, negative 3, x minus negative 3. Whenever you see 0, it's x minus it. Multiplicity 1 means you're going to put 1 here. 1, usually you can ignore it, but let's just put it here. And second 0 is 10, so it's x minus 10. Multiplicity is 2, so you have to put 2 here. And third 0 is negative 4, so x minus negative 4. And multiplicity is 1, so it's 1. 1 plus 2 plus 4 is degree 4, so the degree is 4. It matches the requirement in the problem, so this is fx. Simplified is x plus 3, x minus 10 squared times x plus 4. We just need one polynomial. We don't need to find all of them. Okay, 7. Determine the asymptotes. We have fx equal to x squared plus 6x, 6. This is 6x plus 5 over 2x squared plus 7x plus 5. The numerator can be factored as x plus 2x plus 3. And denominator can be factored as a 2x plus 5, x plus 1. So how do we do that? So 5. No, this is not correct. It's a 6, 5. 6, 5 is a 1 and a 5. 1 and a 5. So 5 is decomposed. First, 1 is just 1, 1. 5 is decomposed as a 5 times 1. You do cross multiplication. 1 times 1 is 1. 1 times 5 is 5. Add them together, you get a 6. So you get x plus 5, x plus 1 as factors. And second one, the leading coefficient is 2. So 2 can be factored as 1 times 2. And 5 can be factored as 1 times 5. So 1 times 5 is 5. 1 times 2 is 2. Add them together is 7. So you get x plus 1. 2x plus 5. And then here you can see that this x plus 1 can be cancelled from top and bottom when x is not equal to negative 1. So after simplification, it's like this. And here you need a requirement. X is not equal to negative 1. X is not equal to negative 1, 5 halves, because 5 halves will make the denominator 0. All right, and once we have such polynomial, rational function, we will see that it has a vertical asymptote x equal to negative 5 halves. You just make the denominator equal to 0, you will get x equal to negative 5 halves. It has a horizontal asymptote. How do you get horizontal asymptote? This one, it is y equal to the ratio of the leading coefficient because they share the same degree. If the numerator and the denominator have the same degree, then the horizontal asymptote will be the ratio of the leading coefficient, 1/2. So y equal to 1/2. That's horizontal one. This is a vertical one. This is horizontal one. Once it has a horizontal asymptote, it has no slant asymptote. Just have those two. Okay, it has no slant asymptote. Okay, problem 8. Problem 8 is just a long formal writing. We're supposed to verify that or prove that 1 to 4th power plus 2 to 4th power until n to 4th power is equal to n to 5th power over 5 plus n to 4th power over 2 plus n cubed over 3 minus n over 30 for n greater than or equal to all positive integers. We prove this by mathematical induction. So first, n is equal to 1. The left-hand side is just 1 to 4th power equal to 1. And right-hand side is 1 over 5 plus 1/2 plus 1 over 3 and minus 1 over 30. If you check this, this one is what? Is 7 over 10. 7 over 10. So 1 times 2 is 2. 1 times 5 is 5. 5 plus 2 is 7. 5 times 2 is 10. And then plus 1/3 minus 1 over 30. And this one is 21 minus 1, minus or plus? Plus 1. Plus 10, not plus 1. 7 times 3 is 21. 1 times 10 is 10. This is a 30. 10 times 30 is 30. Minus 130. 31 minus 130. 30 over 30 is 1. The right-hand side is 1. So we checked. We checked it for n is equal to 1. Now we assume when n is equal to k, the statement is true. With that, n be k plus 1. So we already build the case chain store. We are looking for, we are trying to build the next chain store. Okay, so we have 1 to 4th power, 2 to 4th power, until n to 4th power. N is k plus 1, so it's k plus 1 to 4th power. That's the left-hand side. Left-hand side is like this. This one, if we write one more term before the final term, it's actually k to 4th power. So every time you increase by 1, from left to right. If you go backward, you just subtract 1. All right? So for this one, we just observe the first k terms. We assume the first, when n is equal to k, statement is true. So it means the first k terms, the sum is supposed to be like this. Remember, here is k, so just replace the formula by k. And then plus the final term. Right, plus a final term, and we can simplify it. So k to 5th power over 5 plus k to 7th power, 4th power over 2 plus k cubed over 3 minus k over 30, and plus here you can use the Pascal triangle or just do the multiplication. It is a k to 4th power 4k cubed 6k squared 6k, no, this is a 4, this is a 4, and plus 1. All right, so there is a formula, a binomial expression for this k plus 1 to nth power. You're supposed to know what it is. This is the left-hand side. And then let's check what is the right-hand side. It's a little bit complex, but let's check. Right-hand side, where is it? Here. N is a k plus 1, you will get a k plus 1 to 5th power over 5 plus k plus 1 to 4th power over 2 plus k plus 1 cubed over 3 minus k plus 1 over 30. Okay, long expression. And next, you're supposed to expand those high power. So k to 5th, 5k to 4th, 10k cubed, 10k squared, 5k and plus 1 over 5. And second one is a k to 4th, 4k cubed, 6k squared, 4k and plus 1 over 2. And plus k cubed plus 3k squared plus 3k and plus 1 over 3. And minus k plus 1 over 30. Just expand them. We want to compare the left side and right hand side. So let's check. Here you have a k to 5th over 5. Here you have 5k to 4 over 5. 10k cubed over 5. 10k squared over 5. 5k over 5. 1 over 5. Okay, that's the first term. And second term, k to 4 over 2. 4k cubed over 2. 6k squared over 2. 4k over 2. 1 half. And this one, you have k cubed over 3. 3k squared over 3. 3k over 3. And 1/3. And minus k over 30. And minus 1 over 30. All right. Okay, now let's check. This term, they match, so you don't worry about it. Here, this term, they match, and k cubed over 3. This term, you check it, and minus k over 30, you check it. And now let's check here, k to 4th. 4k cubed. You see 2k cubed, 2k cubed. That's a 4k cubed. 6k squared, 2k squared, 3k squared, and 1k squared. This is a 6k squared. 4k, it's a k, 2k, and k, that's a 4k. 1, I see, 1 over 5 plus 1 half plus 1/3 minus 1 over 30. See, that's our first one. This is exactly 1. That's equal to 1. So we get left hand side is equal to right hand side for n equal to k plus 1 based on the given requirement assumption. When n is equal to k, the statement is true. All right, so we have 3 steps. Steps 1, we examine or check the situation when n is equal to 1. And step 2, we do assumption. Not here. We do assumption. We assume when n is equal to k, the statement is correct. And step 3, we examine the situation when n is a k plus 1. After that, so by mathematical induction, the statement is true. For all positive integers. N. Okay, that's it. It's long. 9. We have function f(x) equal to negative x plus 2 over 5 squared minus 3 over 4. Okay, so let's check first the vertex is negative 2/5, negative 3/4. So it's negative. Negative 2/5, negative 3/4 is something like this. and the opening is downward. It's like this. Then our question asks you identify the intervals on which the function is increasing or decreasing. Here is increasing, here is decreasing. So on the interval negative infinity, negative 2/5, f is crecimiento, increasing. On the interval negative 2/5 and positive infinity, f is decreasing. That's it. Based on the graph, you can easily see the increasing decreasing property. All right. Problem 10, we have a function fx is equal to x plus 3, x minus 4 squared, x plus 6 cubed. So it has zeros. First, negative 3. And possibly we want to know if the graph crosses or touches x-axis. Here, the multiplicity is 1. The graph crosses x-axis, right? It's odd number, odd multiplicity. It will cross x-axis. For the second one, 4, it has an even multiplicity. The graph touches x-axis. And negative 6, the multiplicity 3 is still odd, so the graph crosses x-axis. Crosses x-axis. Okay, so that's touching or crossing. Final one, we have function fx equal to 2x over x plus 3, x minus 2. The function is already factored, so you can easily see there's nothing you can cancel. So the zeros from the denominator will give you the vertical asymptote. The vertical asymptote is x equal to negative 3, x equal to 2. Okay, so this is a vertical asymptote. Because you cannot cancel them, they're really the part of the function. Okay, and if you multiply the denominator, you will see that the degree of the denominator is 2. The degree of numerator is 1. So it will have the horizontal asymptote y equal to 0. If the degree of the denominator is bigger than the degree of the numerator, then the horizontal asymptote will be y equal to 0. This one. This is horizontal asymptote. And then we're going to get the intercepts. Intercepts, x equal to 0. You get a y-intercept. Y-intercept, f0, f0, 0. Y equal to 0, you're looking for x-intercept. You solve 2x over x plus 3 times x minus 2 is equal to 0. A fraction is equal to 0 if and only if the numerator is 0, so you get x equal to 0. So there's only one point. This point gave you the x-intercept. It also gave you the y-intercept. All right? And then if you want to determine the graph, right? Draw the graph, sketch the graph. You're going to check. For example, let's check. Here's 0. Let's check f1, f negative 1, f negative 2. f1 is 2 over 4 times negative 1 is negative 1/2. It's possibly here. f negative 1 is negative 2 over 2 times negative 3. Negative 1 minus 2 is negative 3. So it's a positive 1/3. It's here. If you want, you can also check f negative 2. f negative 2 is a negative 4 over 1 times negative 4 is 1. It's higher. All right. And it's a 3, and this is negative 4. f negative 4. And this 2 and f3. We will check. f negative 4 is negative 8 over negative 1. Negative 6 is negative 4 over 3. f negative 4 is here, lower. f3 is 6 over 6 times 1 is 1. It's higher. All right, so the graph will be like this. Remember that vertical asymptote means when you choose point close to negative 3, the graph of the function will be close will be closer to the vertex asymptote. So it's supposed to be like this. Here is the same thing. And this one, you're going to let it close to vertex asymptote when x approaches it. And horizontal asymptote means when x is bigger or negatively bigger, it will approach this. So that's the graph of this given quadratic, rational functions. All right. So let me give you the complete answers, and you can check this first page, second page, third page, page 4, and page 5. Okay, if you have any question, let me know.